Hello all, welcome to Embedded Linux Learning Point, Linux tutorial, basics of how to work with Linux. In this video, we will look at the introduction to Linux. We will cover what is Linux, a bit of history of Linux. Also, we will see briefly what Linux kernel does. Also, we will see what are Linux distributions. Okay, introduction to Linux. What is Linux? To simply put, Linux is an operating system. So this is just this definition is basically a view from 1,000-story building. So it doesn't say anything about the internals of Linux, or it just assumes that Linux itself is operating system. But that's not the case. Linux in itself is not an operating system, but it is the core component of operating system called the kernel. So you might have heard Linux as a kernel also. So and these days Linux has become the world's dominant operating system kernel by a very wide margin. So a lot of, uh, I mean, a lot of different distributions or use Linux kernel. Since Linux has become the world's dominating OS kernel, where is Linux used? So let's see some of the places where Linux is used, or uh, what are the things that are powered by Linux. So here you can see a list. Your computer is or your computer can be powered by Linux. So what I am using is Ubuntu, and which is powered by Linux, which is one of the distributions. If you can see here in the settings, I can go to about, and it says yes, it is running Ubuntu, and the hardware model is fine. OS type is Ubuntu, and if I just check the uh, there's a command basically uh, to check what is the kernel it is using. So the command is uname. If you say it says Linux, and if I say -a, it actually gives what is the complete information. So it is Linux, and the host is the ELP, and the version of Linux that it is running, the kernel version basically. And we learn all of this in the coming sessions. And the architecture, so basically it is x86 based architecture, and it is called GNU Linux. Okay, so the computer can run Linux, and most of the computers are running Linux also. And supercomputers. So it is said that around 90% of the supercomputers use Linux because of its security and because of its performance. Linux is powering most of the supercomputers. Game consoles. So if you go to any gaming console or gaming studios, so you can witness Linux. So Large Hadron Collider, if you know, there is the CERN Large Hadron Collider, which uses Linux operating system. Amazon Kindle uses Linux. The in-car entertainment, we also call infotainment, uses Linux for its operation. In-flight entertainment, so this is the similar kind of infotainment in the flights. If you travel in airlines or in any flight, you would see in the back, in front of your seat, basically there will be a monitor where you can control, you can get basically you can get entertained with the videos and the content. So that's basically OS running, Linux OS running. Self-driving cars, of course, it uses in cars you'll have a lot of ECUs or or high performance computing units which run which were powered by Linux. Smart refrigerators, washing machines, camera, mobile phones. If you see the Android is basically powered. Basically, I would not say distribution of Linux, but it uses Linux kernel, which is developed by Google. And smart TVs, this is you get a lot of Android TVs and things like that. And smart watches, yes, there are plenty of smartwatches that are available and that run Linux. Network devices like routers, switches, all of these run Linux. And in internet, if you use there are a lot of servers use Linux. You might have heard about Linux servers and things like that. And there is much more that are powered by Linux. So now you know that lot of hardware, or I would say a lot of systems are using Linux. So you can realize that how important it is to learn Linux. So I mean, this is the first step I would say to start learning Linux. Well, let's see a bit of history of Linux. So Linux is not just it was not started, I would say, as a from scratch. It is started. Linux is based on Unix. If you say the Linux is also Unix based or Unix like operating systems. Okay. The first Unix implementation was developed in 1969. So at this time, okay, it is the same year the Linus Torvalds was born, and in 1969 the Unix was implemented, and then it is more of mm, it's a closed project, so it was not open for everybody. And a short time later, Dennis Ritchie is one of Thomson's colleague at Bell Laboratories and an early collaborator on Unix, designed and implemented C programming language. You see, C programming language. Okay, so C is basically you know, developed by Dennis Ritchie, and it is said that most of the internet is run by C because if you see Python, it is implemented in C. If you see, I mean C++, it's basically an enhanced version of C. Under the hood, even Java, if you use Java runtime environment, I think it's I think implemented in C. Also, at least the earlier versions. So I think it's always I think we should remember the names of the people who have uh, helped helped to shape the world that we're living in. So I think Dennis Ritchie is one of the important person, and uh, yes, and the later, unlike Unix operating system itself, C was designed by professional programmers for their own use. The resulting language was small, efficient, powerful, thus modular, pragmatic, and coherent in its design. So that I mean that's the reason even after 40 years we still use C in our programming. And in 1984, Richard Stallman he started working on a project called GNU project. So he wanted to have a free Unix implementation. So Stallman's outlook was moral one because he felt like the Unix is implemented and people and it is a closed one and it costs a lot of money. So that's what he felt he should, or at least we should have a free Unix implementation. So he was not successful to have a complete OS by itself. So at least he had the libraries and everything developed. That's all you will see in the GNU project, recursive GNU means that GNU is not Unix. So develop an entire freely available Unix-like system consisting of a kernel and all associated software packages, and encouraged others to join him. In 1985, Stallman funded the Free Software Foundation, a non-profit organization to support the GNU project as well as the development of free software in general. So he's also one of the important figures in the open source world, and his contributions are highly appreciated. And one of the important results of GNU project was the development of GNU General Public License, GPL, so it's called. So I am not going to get into detail of this, but just to be aware, GNU is, if you say the Linux is free, that's not the case. So if you go through the GPL version 2, 3, 4, and I think recently we have 5 also. I think it has a lot of clauses. So basically, if you want to have a freeware or use the GPL license, that means it's not completely free. You need to uh, basically give your source code open to the community, and uh, I think that's how it works. But at least I'm not fully aware of the GPL license. Maybe I will cover this in the future episodes or in other course or other tutorials. Okay, so among the more well-known programs produced by GNU project or the Emacs text editor GCC, generally originally the GNU-C compiler, but now renamed the GNU compiler collection because it has other compilers, C, C++, Java, and I think it has other compilers. If you have to see the GNU compiler collection, if you see, it has a lot of compilers. C, C++, Objective-C, Fortran, Ada, Go, and D, as well as libraries for languages like libstdc++ and the C library, and all are implemented. I mean, all are available in the GCC. So, so with early 90s, the GNU project had produced a system that was virtually complete, except for the one important component, a working Unix kernel. So the stage was set. All that was required was working kernel to go with otherwise a complete Unix system already produced by the GNU project. So here if you understand, the GNU project produced the other components except the working kernel. So that's where the Linus Torvalds in 1991, a Finnish student at the University of Helsinki. Oh, I don't know how to pronounce this, but Helsinki was inspired to write an operating system for his Intel 8386 PC. So he started this project, and a small Unix-like operating system in the mid 1980s by Andrew Tandium. So he took this as a base, and then he developed early the first implementation of Linux, and it was only supporting the architecture x86 or 386 processors capabilities. So back then it was not, I mean, there was no ARM or any other architectures that it was supporting. So now we can see the Linux supports a lot of other architectures. So let's see the Linux supported architecture. If you see, I think now it supports something like, you see, Alpha, Neos, Alvin. There are a lot of ARM family of Intel Core processors, AMD x86. Okay, so it now it's ported to virtually every, I would say every architecture that's available today. So that's the advantage of Linux as well. And you can see uh, Linux downloads. He's a jovial person. I've seen his interviews. So yeah, and the Towers therefore started on a project to create an efficient, full-featured Unix kernel to run on the 386 for a few months. So he developed earlier the basic version of Linux at that time and ran various GNU programs. So it was kind of integrated his kernel with the GNU programs, and it was working okay. And then he kind of invited other people. I mean, this is a famous post from him. He invited other people to basically asking for help to improve the code and the review and things like that. So the Linux project got kicked off, and then I mean the rest is history. So now we know that everything in the internet more or less runs Linux. I mean powered by Linux. Yeah. So and, and this is the timelines. By March 1994, the developers were able to release version 1.0 Linux. 1.0 Linux wanted to appear in 1995, Linux 2.0 in June 1996, and so on. So currently, if you go to the Linux kernel org, so you can see the latest version is the latest stable version is 5.19.10. So this is the latest version of Linux that was released. I think when I edited this as of 5th September, it was 7, and then you can see the 9, 10 is released. So that's how fast the developments are, and it is supported by. I think the kernel project is supported by a lot of enthusiasts, or I would say the kernel developers, contributors, and which is a well-funded project now. Okay, so let's understand what Linux does, so what Linux kernel does. The core of the Linux system is the kernel, and some of the responsibilities that Linux takes care that needs to do is there are four main functions. So one is the system memory management. So this is the heart of the operating system, right? So it is to manage system's memory. So maybe in other I will cover all of these topics in detail in other course. For example, maybe at least to say a few words. System memory management means to have a virtual memory. Let's say you have, in your hardware, you will have a different memories. Like it could be flash, RAM, or it could be ROM, things like that. All of these memories are mapped to a big virtual memory. So all of this memory management is done by Linux kernel. And software program management, I think this is more towards the execution of the programs, scheduling of few programs, and and all of that is taken care by Linux kernel. The hardware management, it means that you will have a lot of devices connected to your computer, or if it's an embedded system, there are a lot of devices, a lot of peripherals that you would have, and each of this has to be managed, and this is done by Linux kernel. So for example, if you attach an USB, uh, that has to detect USB detected and what kind of device it is, whether it is a block device or a character device, whether it is a memory device, and things like that. So all of this management is done by Linux kernel. And the last but not the least, it's the file system management. Uh, if you see, you have different file systems: ext1, ext2, ext4, I mean ext3 and 4, and also FAT32. All of these file systems is supported by Linux and Linux kernel, and the detecting file and yeah, all those operations. If you see the copying or moving the files or navigating the file, so all of it is done in the file system, and that has to be managed. This is taken care by Linux kernel. It's covering all of these topics in detail is not the scope of this course, but since this is starting our introductory session, I think this is enough for now. So if you understand how important the Linux kernel is to all of the working of an operating system. And the final topic for today is what are Linux distributions. So you might have heard distros, right? So as we know, the term Linux refers to just the kernel developed by linuxtutorials and others, thousands of community members. Okay, now that we cannot call Linux as an operating system by itself, it's just a core component of an operating system. And the term Linux is commonly used to mean kernel plus a wide range of other software, tools, and libraries that are together make complete operating system. So that's how it is. So if you see here, you are, for example, you are a user, and that user needs to work, interact with applications. That applications interact with operating system, and operating system interact in the hardware. The way it does is like this: application software, and those interact with window management, and window management software is basically or I would say the GNU. Here you have a GNU system utilities and the other services, for example, and those interact with Linux kernel, and the Linux kernel takes care of interacting with the computer hardware. So that's how the complete OS operating system is built. And here if you see the four main parts are Linux kernel, the GNU utilities, a graphical desktop environment, and application software. So in the graphical desktop environment, you have there are different things, the genome, the KDE, and things like that. I think the whatever we see here, if you see, this is a graphical, the desktop environment, for example. And if I have to show you what is the desktop environment that I use, or that is part of Ubuntu 22.0.2, sorry, 22.04, I think, the version of Linux that I use. You can see, yes, this is the desktop genome version 42.4. This is the desktop version. But anyways, we will see all of this in the future. We have different desktop environments. Yes, so that is how a complete operating system is made. But here, with Linux, since it is so much customizable, so you can build Linux of your own. You can build your own Linux distribution. So if you see my uh, other channel where I have done Linux from scratch, where I have built a complete Linux operating system. Of course, you can say a very basic operating system where I can interact through just the command line, and that it provides that freedom to basically build your own system and then have it working for you. So each individual or the set of people have their own preferences of what your operating system should consist. So that is why uh, people started building their own version of operating systems or distributions. It's basically to suit for a different need. Okay, so in a very Early days of Linux, the users was required to assemble all the software, create a file system, and correctly place and configure all the software on the file system. So, so this demanded considerable time and expertise. As a result, market opened up for Linux distributions, who created packages or distributions to automate most of the installation process, creating a file system and installing the kernel and other required software. So, like this is something like uh, let's say I build a distribution or I build one operating system and then I release it to the community or the public and I say I call some name. So that's how you have a lot of Linux distributions available. A typical Linux distribution comprises a Linux kernel, GNU tools and libraries, additional software, documentation, a Windows system, the most common being the X Windows system or more recently Wayland. Okay, I think what it uses is Wayland. Sorry, I said Genome 3. Genome 3 is Genome version. Genome is a desktop environment. If you see, yeah, the Windows windowing system is Wayland, and it is the Genome version 42.4. That is the desktop environment. Okay, now I correct myself. Okay, so and a window manager, a desktop environment. Yeah, desktop environment is Genome and things like that. So it your distribution can have oh, anything that is needed for you. So it works like that. Linux distribution may also be described as a particular assortment of application and utility software, various GNU tools and libraries, for example, packaged together with the Linux kernel in such a way that its capabilities meet the needs of many users. So that's how a Linux distribution is born. Some of the popular distros are MX, Linux, Manjaro, Linux Mint, Ubuntu, Debian, Pop OS, Elementary OS, Solus, Zorin OS, Fedora, Deepin. Some more information on distros can be found at distro watch and wiki page. Okay, so yeah, let's just understand a little bit of on this distributions. Let's go to this wiki page. How do I open it? Okay, control and press it goes to wiki page, and we have a distro watch. This is a page where distributions are basically listed. See, there are somebody has put a periodic table of Linux distros. Looks looks good. Yeah, I think this is taken from here. If you see, uh, it's a very big image of Linux distributions. But what we need to understand with this, with respect to distributions is there are some distributions like Ubuntu, for example. It's very familiar with the people who are not, I mean, who are, uh, I would say, who want to use the system, like who want to migrate from Windows, for example, and to start working on Linux. So Ubuntu gives you that freedom or ease of use, I would say. Yeah, so if you see, there are a lot of distributions. If you see, Ubuntu has come here. And from that Ubuntu, there are other distributions are built on the top of this. Ubuntu Mate, Century, Ubuntu Genome, Redo. So you can pick the one which you are comfortable with. So as I know, this is a lot of programmers use Arch Linux because the Arch Linux is something like uh, it gives you a lean installation and it is you can configure and install or control everything that needs to run on your system. So Debian is or Ubuntu is based on Debian. So these are basically different distributions that are available. You can pick one and then change it, or choose the one which you like. So that's the key takeaway here. So one important point to consider with the distros is that each distro has its targeted audience or users, and each distro have their own pluses and minuses. So basically, to suit the needs of the user. So that's how the distributions are built. Well, so I'll end this session with this note. Feel free to choose any distribution and install it and explore. Start exploring. Start working with Linux. And here in this series, I'm going to help you with uh, with how to work with Linux. Basically with command line, and basically I use the Ubuntu version of it, Ubuntu, with the command line and also with the GUI. So how to do things, or how to achieve some of the tasks that you want to achieve. So yeah, so that's about this session. I hope you understood what is Linux, how some history, and what are the components of Linux OS, and what is powered by Linux. Yeah, that's all for this episode. Please do subscribe to this channel for uh, more videos like this. Thanks for watching.